My name's Andrew Brust, and in general, what this session is meant to do is kind of take stock of the analytics stack, for the most part on Azure, but there's pieces of it elsewhere, that has assembled itself over the last year or so. But do that in a context so that it's approachable for those of you who are coming from really working mostly with OLTP databases, straight relational, SQL Server, relational engine, or BI, if that's in the Microsoft world, maybe with analysis services, and if it's with a competitor's BI stack, so be it. There's a lot of pieces that have come up, and it just makes sense to try and stitch them all together, and hopefully to see them in some strategic kind of viewpoint, because there's so many options and so many choices and so much hype around all of this stuff that cutting through it seems a worthwhile pursuit. So my background, without sort of reading bullet after bullet, is that most of my career I've been working with the Microsoft stack, either as a developer or owning a consulting firm, a small consulting firm, or then helping run the slightly larger consulting firm that bought my small consulting firm. And then more recently, kind of doing stuff actually as a journalist and as an analyst in the big data world. And then most recently, joining this company called Datamere, doing technical marketing. So you'll also see me once every other month writing a column for Visual Studio Magazine. So that's the gist of it. Focusing on big data recently, but with a long background in Microsoft BI and Microsoft Developer Tools, and not just .NET, going all the way back to Visual Basic 1.0, actually. So that's me. And then that's like an old screenshot of my blog on ZDNet. So it says it's my new and old blog, because I actually started a few years ago for them, and then I took a full-time job as a research director for big data and analytics at a research firm called GigaOM Research. And I don't know if you read the trade press or even the mainstream press, but almost exactly 2 months ago, GigaOM went out of business at the end of the day on a Monday. They said, you're going to want to wait till about 7:30 tonight, because I was in the New York office and headquarters was in San Francisco. So we had to wait until 4:30 their time to find out that there wouldn't be a Tuesday. But Datamere is a company that I had followed for a long time. And I was able to come on board then. And so I'm back at ZDNet, because I've been writing for most of my career, going back to the mid-90s for what was then called Visual Basic Programmer's Journal. I'll let you guys know, if you want to make a fast escape, I understand, stay where you are, but otherwise there's lots of seats right up here, and you won't hurt my feelings if you come up. No reason to stand on ceremony. So then the other thing, just again to reiterate my Microsoft background, is that I co-authored this book with Lenny Lobel on SQL Server, and this was aimed to developers, still is aimed to developers. This started as a SQL Server 2005 book, actually, and we've updated it twice. Perhaps we'll update it again for 2016. We'll see. But again, the goal of this talk is if you kind of fit this profile where you've been using mostly relational database technologies, coding line of business applications, so-called CRUD applications, an acronym I've grown to find out that in the big data world, people don't even know what that means. There's a whole culture split between the big data world and the enterprise software world. So I don't know. That's an interesting phenomenon in itself. But if you're on this side of that cultural divide, if you've been doing a lot of stuff just with production reporting, or if you've been doing stuff with analysis services and MDX, I guess I found out before the session started that a number of you are actually working with the tabular mode of analysis services, and ostensibly with DAX as well. I didn't put it on the slide just because I didn't think adoption was that good, but imagine that bullet on the slide. If that's where you are, but you've also, been reading about and hearing about big data, machine learning, artificial intelligence, a term you thought went away in 1980 something, and all this stuff is nagging at you, and you figure, well, I finally need to kind of pay attention to it and see if it has legs. Then the session is kind of there for you. If you've been reading about Hadoop, if you've been wondering about cloud data warehousing, which is an interesting one in and of itself because Microsoft just announced it's entering that market, machine learning, and maybe NoSQL, hopefully what we can do is make some sense out of all this stuff. Before I do that, though, let's just talk about why these changes have come around. I mean, to some extent, it's because there's a new generation of developers, and they're looking at relational databases, and they're saying, you know what would be really cool is if we had a database that didn't have any schema. That would just be fun, and I could prove that it works. But no, there are other reasons. A lot of the new technologies are built around open source technology, mostly on Linux, for what that's worth. And there's just an awful lot of activity and enthusiasm in these communities. And it might strike you that that by itself isn't a good reason for something to become a phenomenon, but it has its influence, especially in startup companies. And then whatever happens in startup companies kind of gets, I've learned, magnified just because of the way venture capital works. And when venture capitalists see something happening in one corner, they get the sense that it really should be happening in every company they fund, and then suddenly it becomes a phenomenon. That's a real thing. Another thing that's happening is these new data technologies are not based on proprietary appliances or very expensive enterprise storage. It's based on the idea that you can use commodity machines. Now, commodity machines doesn't mean cheap machines necessarily. These are still going to be servers with, most likely a lot of RAM and a lot of disk, and nothing necessarily cheap about that. But because you can use really anybody's stuff, and kind of avoid getting price gouged, especially on the storage side, that's had a lot of influence as well. Scale out has been really important, and cloud has been important because of that. And what's interesting is in big data, we want to scale out not because we have lots and lots of users and lots of sessions, we just have lots and lots of data. But meanwhile, in the so-called web scale world, it's the other way around. We have lots and lots of users, but both of these have kind of fed off each other. They've created the need for software and a whole approach to making it really easy to just add machines and take on bigger and better scale and deal with the fact that those machines may fail and there needs to be a failover mechanism, and that just circles back to the whole commodity thing again. The cost of compute has gone down. I mean, you could revisit me every 5 years for the last 20 and every 5 years for the next 20, and I could put that on a slide. But it's gotten past a threshold now where we don't really have to worry so much about the compute cost. The cost of architecting and just kind of, building the system and thinking through it ends up being more significant maybe than the hardware spend. And most important of all, I think, is that storage has become much, much cheaper. It too has crossed a threshold such that, at least as the common wisdom goes, how true this is a different question, but at least as far as the common wisdom goes, it's cheaper just to save the data, just to store it, just to put it somewhere, than it is to make the decision about whether or not you should keep it. So now we're in a very different kind of environment where we can pretty much assume that all the data that got generated is going to be there. And there's also kind of a default assumption that there's value in analyzing it. And I think a lot of the time that's true. I would say there's almost an article of faith around that is probably overdone. But when you put all of these things together, that's why new technologies have come about. We need technologies that take advantage of the scale out. We need technologies that, almost justify the fact that we're keeping all the data around. And again, the fact that the commodity basis is there and that the storage and the compute are cheaper now makes that thing pretty self-sustaining. So just as a reminder, Microsoft has stacks around, kind of all this stuff. On the on-premises side, we've got analysis services. That's been around since SQL Server 7 in the late 90s with its multidimensional mode. And then with the release of SQL 2012, really, we got the tabular mode of analysis services. And that's based on column store technology. And I'm going to talk about column store technology all by itself in a little bit. Just because that, too, all by itself is a very important part of what's going on. For streaming data, we have Stream Insight. For ETL, we have integration services. There's been a data mining engine in SQL Server, actually all the way back to SQL Server 2000. It became usable in 2005. And it's been sitting there without a lot of adoption and without a lot of use for 10 years. But it's been there. We have the analytics platform system. How many of you have heard of APS? Okay, that's less than half the room, about what I expected. How many of you have heard of something called PDW, Parallel Data Warehouse? Okay, it's actually the same thing, so now you know what APS is. It's just a rebrand. But that's a data warehousing appliance from Microsoft. And then we've got all these different add-ins for Excel that actually add quite a lot of value as well. So on the on-premises side, that's our motley crew of stuff. By and large, that's not what we're going to be talking about today, but most of these things have analogs in the cloud. So first of all, in the cloud, we have HD Insight. That is Microsoft's version, release, spin approach to Hadoop. Hadoop being the major open source big data software framework. And we'll talk about Hadoop, and I'll show you a demo of running a so-called MapReduce job on Hadoop, so you can see what that's really about and see how awfully primitive it is. A lot of this stuff is crazy primitive. It's like going back to mainframes. And it's important to just kind of have an expose on that because until it really has all the sophistication that we're used to with relational and BI, it's not going to be that effective in the enterprise. But that time is rapidly approaching. Azure Machine Learning, Stream Analytics for streaming data, Data Factory for, in effect, cloud-based ETL. Something that was just announced last week called the Azure Data Lake. I have that in a different color because it's in preview. Something called Azure Data Warehouse, same deal, it's in preview. Power BI 2.0 has some improvements on Power BI 1.0, you would certainly hope so. Don't you love how whenever Microsoft comes out with a new version of something, they say this is the best version we've ever released? You would hope so, right? So this is the best version of Power BI they've ever released. But we want to take a look at it. That too is in preview. DocumentDB, which is Microsoft's NoSQL database in the cloud. And then Microsoft recently bought a company called Revolution Analytics, which has an enterprise appropriate version of the R programming language. And it's not that the language has extra features so much as they've designed it to work on distributed computing infrastructure instead of on a single node. And it's a big deal that Microsoft bought the company. We'll see how that stuff ends up getting integrated in the stack or not. But just as a statement in and of itself, it's important that Microsoft did all that. So, each one of these has sort of come up in the last several months without necessarily a lot of fanfare. And I don't know, it sort of snuck up on us. But if you look at that, that's a whole big stack. It's at least worth understanding what each of those pieces does. And anyway, that's part of what we're going to do. The ones in purple are the ones I'm going to demo. So we're going to look at HD Insight, we'll look at machine learning, and we'll look at Power BI 2.0 in two different capacities. One, just against straight relational data, and then again, going against data that's in Hadoop. So first, I don't know, the easiest way to start out is probably to talk about the data warehousing options that you have or soon will have. And I like to start here because data warehousing is just relational database, right? This really is just SQL Server used in a more I don't know, high capacity kind of scale out scenario. But this is technology that we all understand, so it's a good place to start. The first thing you need to keep in mind is that SQL Server Enterprise in and of itself is a good platform for building a data warehouse. So a data warehouse is really just a relational database that's been designed around a schema whereby most of the data you want to look at, the numbers you want to look at are in one table, and most of the categories you want to drill that data down by are each in their own tables. And that arrangement happens to be called a star schema. You can do that very nicely in SQL Server Enterprise. There's a feature that came in SQL 2012 and got better in 2014 called column store indexes that I'll talk about that make SQL a really good data warehousing platform that can be really fast. So that's your first option. Don't assume that to get into this world you have to go into these specialized versions of the product. But if specialized versions of the product are okay with you, then you should know that there's this thing called the Analytics Platform System, or APS. That has a parallel version of SQL Server inside it. Basically what that means is it's an appliance with lots of SQL Server instances in it, and then one instance in front of all the others that you can send queries to, and it will do all the work of sending different pieces of those queries out to different nodes inside the appliance. But meanwhile, you can just look at the whole thing as one logical database that you query in T-SQL. It also has a very special technology in it called Polybase that I'll talk about. And, Azure Data Warehouse, which was announced recently, that's effectively a version of APS in the cloud. And that's really important because an appliance-based version of SQL Server, in terms of adoption on premises, there are some important customers that were doing it, but it wasn't as widespread as, say, the Enterprise Edition has been. So specifically, let's talk about Polybase. Polybase is a wonderful bridge into the rest of the discussion because it's also a bridge between SQL Server and Hadoop. So the APS, Analytics Platform System, includes the parallelized version of SQL Server that I just talked about. By the way, the three-letter acronym for that architecture is MPP, Massively Parallel Processing. And again, it's this idea that you actually have numerous instances of the relational database in one rack, and then you have one instance in front of it that you send queries to, and it's the traffic cop, and it sends pieces of those queries out to the other nodes. Then what got added to the second version of PDW is this thing called Polybase. And Polybase was brilliant technology. The frustrating thing about Polybase was that it was only available in PDW, which was a version of SQL Server that just didn't have that much uptake. But what Polybase does is it reaches into the data that's in Hadoop. And we haven't talked about Hadoop yet, but we will. And it makes the data in Hadoop look like it's a table inside of the SQL Server database. You do a create external table, right? So it's actually a create table command. And you reference files in the Hadoop file system, and it understands how to make that look like a table. And from there on, you just query it using T-SQL, and you can write joins that join the physical tables with those external tables, or that just talk to the external tables directly. And the thing about Parallel Data Warehouse is it's already a parallelized version of the database. It's already got a query optimizer, a sophisticated cost-based query optimizer for that, so it knows what to do. So instead of delegating all that work to Hadoop, we actually have SQL Server talk to the data nodes directly, okay? And where it's advantageous, we actually do delegate some of the work down to Hadoop so that it can happen over there rather than all the data getting moved and then getting processed by SQL Server. So it's really the best of both worlds. We can bypass this MapReduce processing that I'll talk about if we want to, or we can mix and match MapReduce processing with relational database MPP processing. So the other thing about APS is if you want, you can buy it with Hadoop already installed on the appliance as well. So So you can have Hadoop and a parallelized distributed version of SQL Server all pre-installed, all inside of one appliance. That's a very nice thing to have. But there may be reasons why you don't want to do that. Cost may be one of them. The fact that the scale that you are anticipating could grow and shrink, that your needs, in fact, are elastic. That's hard to really deal with a physical appliance, right? You might outgrow it, or you might be kind of overbuying. So that's one of many reasons why Microsoft just announced this thing called Azure Data Warehouse. And I wrote about this for ZDNet. It was announced at Build last week, I think on Wednesday, so it's not even a week ago. And what this does is it takes Azure SQL Database and Parallel Data Warehouse, and it kind of puts them together as a cloud offering. Polybase is in there, which means you can be in the cloud and you can use it to talk to a Hadoop cluster that's also in the cloud. And at least theoretically, you should even be able to talk to a Hadoop cluster that's on your premises. So I know I'm kind of going back and forth, but the point is, if you're just looking to break into this technology, you can do it like kind of all at once, cold turkey, dive in, just do Hadoop. But what you can also do is a more gradual transition and do it from a piece of software that makes it all look like SQL Server and maintains the T-SQL skill sets that you or a lot of folks on your teams may already have. Azure Data Warehouse also has integration with Azure Data Factory that we'll talk about, and Power BI that we'll both talk about and look at. How many of you have heard of an Amazon Web Services product called Redshift? So Redshift is Amazon's cloud data warehouse, and this is Microsoft's competition to it, which is a while in coming. Microsoft's doing something a little different, though, because the way things work with Redshift is you tell it how many nodes you want in your cluster. And each node has a certain amount of compute and a certain amount of storage. And if you want more of either one, then you add more nodes. So what that means is that compute and storage actually scale together. Microsoft takes a different approach. They say, well, the storage is going to be in Azure Storage. So you can scale storage as you need to. You can also scale compute as you need to. So they actually move on independent axes. And you can even pause the entire data warehouse when you're not actually running queries on it, because, again, the storage is persistent in Azure Storage. That's very different from Redshift, where you have to tell it how many nodes you want, and those nodes are up and running 24/7, and you are paying for those virtual machines on a 24/7 basis. So Microsoft's taking a different approach architecturally. It's taking a different approach economically. And again, this is very new. All right, I promised I'd talk about column store technology. So let's do that. Column store engines are one way into this world, and in SQL Server, another way into this world is with a special type of index called a column store index. But they both work on the same principle. I'll demonstrate that principle in a second. But be aware that the tabular version of SQL Server Analysis Services uses this technology. Power Pivot uses this technology. And again, the column store indexes use this technology. Here's what it's all about. Imagine this very, very simple database table. It's an employee table, and because it's just for the purposes of explaining a concept, it only has 3 columns, an ID, and a couple of value columns, one with age and one with income or salary. Now, imagine if we kind of turned that on its side, and instead of putting all the row values next to each other, we put all the column values next to each other, right? So you see that all those income numbers are next to each other on the bottom. Now, why would you do that? There's a few reasons. First of all, in BI and analytics, we tend to be doing aggregations on 1 or 2 columns only, and we tend to do big table scans when we do that. So rather than having to skip over all the other columns that we don't really care about, it just makes sense to put all the values for the column that we do care about next to each other, right? It's just less work to scan it. But it really goes beyond that. Because once you put those values next to each other, some other things happen. And I've stacked the deck here in my favor, just, again, to prove the concept. But the values end up repeating sometimes, or they end up being very close in value and certainly in order of magnitude. And what that means is, instead of representing each discrete value, you could really represent a base value and then a series of offsets, which means you can represent that 9,000 and 10,000 and 10,000 without actually using up all the bytes that it would take to express those values. That's a long-winded way of saying we can get really good compression when we have a column store scheme. And if we can get a lot of compression, we don't just sort of save on storage. That's not the important part. The important part is we can then put huge parts, if not the entire database, into memory. And as soon as we can do that, then we can start doing analytics really, really quickly. So the column store indexes in SQL Server allow you to do this kind of thing just in the relational database, which is really valuable. And then if you're using Power Pivot or the tabular mode of analysis services, you're actually getting a storage engine that works on this basis as well. This is relatively new to the Microsoft stack, and it's pretty common across almost all the BI and analytics products out there. So you should know about it. It's also going to be present in Azure Data Warehouse. So, and just to be a little more concrete about that, when Power Pivot was still in beta, and it was called Project Gemini, just to sort of time when that was, this is when netbooks were really popular. And the demos that the team was giving of the product, typically they were doing the demo of the beta running on a netbook with 2 gigs of RAM. And they were loading fact tables with more than 1 million rows of data. And the performance was actually pretty good. They were able to load that database in under a minute and then do aggregations and queries on it very, very, very quickly. So that's valuable technology. And again, as I said, all of it is inside of Power Pivot and therefore Power Query and Power View and Power BI. So first I just want to show a quick demo of how the various Power tools, if you will, work together. This is Excel 2013, and there are no big data tricks up my sleeve yet. All we're going to do is go into Power Query, and we're going to hit a version of the Northwind database, which everybody should, I think, find accessible. There's a few extra tables and views in my version of Northwind so that we can quickly do some work on this. So we'll hit my local server. We'll hit the Northwind database, and we'll go ahead and click OK. And what I'm going to do, I built my own fact table where basically all the sales data is broken down by date and zip code and other granular stuff. I have some views so that we can drill down on all of those things. So I have a view for employees, and another one for geography, and another one for products, and a similar one for suppliers, another one for shippers. I have a physical table for time, and I also have that fact table that I told you about. So I've selected all of those. Let's just do some quick editing on this a little bit. And first of all, I just want to, this will be a little tedious and seem a little strange to me, but I want to get the names on these things right, because this schema ends up being, sort of the pick list of all the things you see when you go to do analytics. So it's nice to get it clean from the beginning. So we'll get rid of these VW prefixes that came from the views. And then I'm also going to do, when we get to the fact table, I'm going to do some cleanup there as well. So bear with me, we're almost there. Suppliers. Let's get rid of that prefix. And shippers. And that one. Click OK. Click Apply. And then we'll also do it for time. And then finally on the fact table, what we're going to do is not just change the name, but let's change the schema a little bit. In fact, I don't want to call this fact, I want to call it sales. So we'll do that. And then there's some columns in here that I don't actually need. I don't need the required date. I don't need the ship date. I don't need the ship country or the ship region. And I also don't need this time key. So I've highlighted all of those, and I'm just going to hit the delete key on my keyboard, and all those columns go away. And that cleans it up a little bit. The remaining things in there I have to leave in because they're going to participate in relationships out to the other tables. So I'll go ahead and close that. And then we can click this Load To. Let me zoom in here just so you can fully appreciate what's going on here. So when this checkbox comes up and it says add this to the data model, what that actually means, this is now built into Excel, which is why it's just called the data model, but that really means add it to a Power Pivot data model, which means we're running a column store on the local machine here, and instead of putting that data in the spreadsheets, I'm putting it directly into that engine and into that model. And that's important because historically what's happened when people have done analytics in Excel is that they've done it off of data in the spreadsheets. And that's sloppy, and it's also scary because people can change those values either on purpose or by accident, and it really can create some chaos. The thing to understand is that the current version of stuff that works in Excel is not just convenient, it's also a lot safer and a lot more rigorous. And, you know, sometimes that manifests itself into little radio buttons and checkboxes. So in this case, we are just creating the connection. We're not going to load the data into the spreadsheet itself, and we are going to load it into the data model. And we're going to zoom out. And all this data is going to load in now into the in-memory columnar engine. And what that'll let us do then is go ahead into Power View and do a quick report on it. That'll be our next step. So far, again, we're only in the world of relational data and BI, but what you'll see in a subsequent demo is that to go against Hadoop, data in Hadoop, we can do it almost exactly the same way. So what I'm going to do next here is go to the Insert tab and click on the Power View button to add a Power View report. And almost immediately, I can start dragging and dropping things. But I first need just to set up the relationships between those tables. So give me a second here. This is just one last tedious set of steps. So we want to go from, everything's going to be from sales. We'll go from into the employees table on employee ID, and we'll click OK there. We'll do another one where we'll use order date, and we'll pick time. There are going to be 5 of these altogether, if I'm remembering correctly. So actually 6. So here's sales, and this time we're going to do postal code to get our geography. 3 to go. 1 more. Sales. And this time product ID into the products table. We're going to reuse product ID to go to the suppliers table. So let's do almost the same thing again. Here's product ID, this time to suppliers. And then only one more, and that's going to be the shipper ID into shippers. And we'll click OK. And we'll close. So now we're ready to build a report in Power View. Let me zoom in here, because that font just won't scale no matter what you do. So what I first want to do is grab, let's say, the countries in my database and the total sales associated with each. Okay, let me zoom out. That will, by default, go into a table, but we can just resize that and very quickly change it into a column chart. There we go. And then what I want to do is I'll grab, this time we'll do the unit sales, and we'll do it against shipper. Actually, let me pick shipper first. So shipper name, unit sales. Let me move that down here. Let's resize it to be the entire bottom half. We'll go ahead and make that a line chart. And we'll do a couple more things here. Let's find geography. Actually, let's find employees. And we'll bring in the employee name. And we'll make that into a slicer. So now this isn't data we're looking at so much. It's data we're using as a filter. And then maybe I'll do the same thing with year out of my time dimension. So there's year. And you see that what happened here is that it's treating year as numeric data rather than in a sense, text. So let's quickly fix that. We'll just go into time. We'll edit it. And we're going to change the type of year to text. Okay, and we'll close it and load it again. And that should just kind of update itself. And this is nice, too, because you get to see that there's a fluidity between the two. So now that I've gotten rid of that, now I can select year one more time. And now we actually see the different years from the Northwind database, which is 96, 97, 98. We'll turn that into a slicer as well. And then as a last step, I'll bring in as a series, I'll bring in the product category from the products table. And so far what this looks like is a bunch of static charts. But let's be real clear here. I can click on any one of these bars in the bar chart, like USA, and watch what happens to the line chart down below it, right? It updated. Okay, I could also hold down the control key and pick multiple countries, so hello. Don't you love Windows 8? And then I could pick USA and UK together, there we go, and you get the idea. I could also clear that out. And I could pick an individual category, beverages, confections. Let's do something, let's go back to beverages. Let me zoom in there just so you can see there's two different shades of blue there. So the darker blue is the number associated just with beverages, and then the lighter blue is the unfiltered value. And then, of course, we could click on any of these slicers, and that would kind of filter everything. And you get the idea. And it's all coming back very quickly. That's something you tend to take for granted. But that would be a lot harder if we didn't have column store technology behind it. And that's a big deal, right? It means that you can ask your questions iteratively. You can be very exploratory. You can say, all right, let me look at this, and now that I understand that, let me ask another question and another question. It's a lot different from creating a report in reporting services, and then when your user kind of ends up being fickle and says, well, can you change it a little bit, right? And that ends up being a huge burden. Well, here that's not the case. This is designed for that kind of exploration. By the way, have you guys seen these bubble charts and how you can animate them? I'll take this one more step. Let's get the ribbon back here. And if we change the type of chart here to a scatter chart, and we still need the field list here, though. Hold on. There we go. There's the field list. I want to get this. Let me get this category name out of here, actually. And let me pick the other two sales numbers, the total sales and the discount. And let's see what we can also do. Let's turn off these filters. And then finally, if we come back here, I can put year in something called the play axis. So pretend that filter's not there anymore, because it wouldn't make sense to filter on something that we're also graphing. I could put that in the chart. I could maximize this guy. And then because the time is going along this bottom axis, this secondary x-axis, I can click this little play button, and you can actually see the values kind of animate as you go through the time in the calendar. And then if you're interested in the data for a particular shipper, you can highlight that, which is really nice. Again, the idea is once you build the model, there's so many things you can do with it. You can do stuff in Power Map as well with the same model. It's really only a few clicks away. And again, it comes back pretty quickly because we've got this column store engine behind it. Let's go back to the slides over here. And let's talk some more. So now I want to move into the world of big data. And let's talk about a definition. Okay? The thing to understand about big data is that it has been really measured in terms of how much data you had, and that's really changing to be also about how quickly the data is coming and how structured or unstructured it is. That's the first thing to keep in mind. The second thing to keep in mind is if I tell you, well, it's not really big data unless you have a petabyte or at least hundreds of terabytes. Right, I guarantee you in a couple of years that line will move, right? And we'll be able to handle maybe petabyte scale in a relational database. So I think the best definition for big data is one where you have a volume of data or a volume per unit of time of data that exceeds the capabilities of whatever the current operational databases can handle, right? So today, if you're in petabyte scale or if you're doing really heavy-duty streaming, that's not something you want to do against a relational database. And it is something you can do against Hadoop. The thing about Hadoop, though, is that it was born on the principle of processing data through this algorithm called MapReduce. How many of you have come across MapReduce? All right, a few of you. So MapReduce, I think, is really backwards. And it's powerful in that it works in parallel. It works on distributed systems. So if you can get it just right, it can take on huge volumes of data and deal with it very quickly. But you pay a big price for that. Let's sort of talk about what it does. First of all, like an MPP data warehouse, what it'll do is it will take the data set, the input data set that you give it, and it will chop it up into lots of little bits. And it will operate on each of those little bits on a different node in the cluster. And I'm going to have this graphically in a second. But mappers, there's a two-step process here, a two-phase process. The first step is really just to parse the data and parse it into a key value format. The second step then is to take all the values for a given key and reduce them, hence the name MapReduce, reduce them down to a single value. Oftentimes that just means adding them up, right? And so the MapReduce is really just a way to pre-process the data into keys and values and then do a quick aggregation on those values. But the way it works is you actually write procedural code for the map step and more procedural code for the reduce step. And natively that's done in Java, although there's ways to do it in other languages. So let's look at that graphically if we can. You start with the input data set. You break it down into several others. There are 6 on this slide, but realize those 6 are symbolic for what could be hundreds or even thousands of pieces. Each of those pieces becomes the input file for the map code to run on a node in the cluster. The map code puts things into key and value format, and it creates additional files, the output files, then all the data in those output files get shuffled. They get collated so that all the values for a given key are put contiguously. They're put next to each other. And then those collated files become the input files for the reducer nodes. The reducer nodes go through all the values for a given key, and then they come out with a single value. Again, that may just be a matter of looking at all of them, keeping a running total, and then when the key changes, you've got your aggregation for that particular key. They create output files that are sequence files, and if you put all those sequence files together, you get the output. I mentioned that we can do this in in Java or in other languages. In a second, I'll demo doing this MapReduce approach using some code that's written in C#. Before I do that, though, let me show you what has been in a typical Hadoop distribution. So at the bottom, you have Hadoop itself, which is really just an engine for doing MapReduce and a distributed file system, meaning software that takes all the disks on all of the nodes in the cluster and aggregates it together and makes it look like one big storage volume. So it's a distributed file system, the Hadoop Distributed File System, or HDFS, right? That's what Hadoop 1.0 is. And then most distributions also include a database, a NoSQL database on top of HDFS called HBase. These abstraction layers over MapReduce called Hive and Pig. Hive is actually queried using a dialect of SQL. Pig is queried with its own language called Pig Latin. And you get lots of these cutesy names in the open source world. There's a piece that will move data back and forth between HDFS and tables in a relational database. That's called SCOOP, which is an acronym or a contraction for SQL to Hadoop. There's even a machine learning engine called Mahout. And all of these things, Mahout, Scoop, Hive, and Pig, have their own kind of domain-specific languages or command line interfaces. And then what they're doing is effectively generating the Java MapReduce code to get the work done. And then there's also been this piece for working with log files called Flume. Now, Microsoft's flavor of Hadoop is Azure HD Insight. It was developed with Hortonworks, which is one of the bigger Hadoop distribution vendors. The two biggest are Cloudera and Hortonworks. Microsoft partnered with Hortonworks. And the substance of their work was to port Hadoop from Linux to Windows. No reason that you can't do that because it's all written in Java. Java runs on Windows just as easily as it does on Linux. So that's what they set out to do. And Azure HD Insight is the result of that. What it also does, though, is instead of using native HDFS, it actually uses Azure Storage. All of this was contributed back to the open source project, by the way. So the branch of the code that's Hadoop on Windows is actually open source. Just to make matters a little bit more confusing, there is a Linux version of HD Insight that's in preview right now. So even though Microsoft went to all the trouble of porting Hadoop to Windows, in fact, they are supporting their own Linux version of the distribution. That's in preview. And then there are things you can do on premises if you don't want to be in the cloud. There's a single node emulator for developer purposes that you can download and run for free. And that's kind of neat because then you can write MapReduce code in C# and even debug it. Hortonworks makes a version of HDP. It's Hadoop distribution for Windows that you can run on premises or, for that matter, in Azure Virtual Machines. And there's also, don't forget that if you get the Analytics Platform System appliance, you can get it with HD Insight pre-installed on the appliance. So this doesn't have to be a cloud-only thing, but we're gonna look at it in the cloud. So let's go back to my laptop now. And what I'm going to do, actually, is bring up, of all things, the PowerShell environment. because one of the ways to work with Azure HD Insight running on Windows is to use PowerShell. And what I can also show you is that we've got some MapReduce code written in C#. What this implements is sort of the hello world of MapReduce, which is something called word count. And all word count does is it takes an ebook as a big text file, and it loops through that ebook one line at a time, and it divides the line of text that it found into an array of words, and it uses those words as the key, and it emits the value 1. So you take a big file, you go line by line, you take all the words in a line, and you output each word with a value of 1 next to it. That's all the mapper does. And then all the reducer does is it sums up the number of occurrences of each word. So what it'll do is actually go through, and by the way, this is the mapper, here's the reducer, and you can see it's checking to see if the new word is equal to the previous word, and it's keeping a counter down at the bottom. Here's where it increments it. And then finally what it will do is it will output the word and the total number that it's racked up. So this will take an ebook and it will produce a list of all the words in the book and the number of occurrences of each word. Very simple stuff. And you can see that what we're doing is very primitive processing where we're just taking data off of standard input and putting it on standard output. These are C# console applications. So if I go back over to the PowerShell environment, I'm just going to set up some variables around my Azure subscription and my storage account. I'm going to highlight those lines of code and hit the F8 key. And that will then enable me to upload the executables for the two pieces of code you just saw. So here's my mapper.exe and here's my reducer.exe. So these two lines are going to upload those executables to the head node on the Hadoop cluster. So let me highlight those and hit F8. Okay, so those are now uploaded. One more variable where we put the name of my cluster into a variable. We define the MapReduce job. That's a lovely commandlet name. New-Azure HD Insight Streaming MapReduce Job Definition. And then once that's done, we can go ahead and actually run the job. So this will take a minute to run. While it's running, let me point out what might be obvious to you, but it bears making explicit in any case, which is that MapReduce is batch, right? This is a job. This isn't just code that we're running interactively, right? We're uploading the executables, we're packaging it up in a job, we're submitting the job to a job processor, and eventually it will kick off the map process. And when that's 100% on all nodes, it'll kick off the reduce process. And you might not even, you might lose hope and think that nothing's even happening here. But if you look at the bottom left, it does say that it's running the script. So we know it's running. We're getting a little bit of output here. Eventually, we will see a percentage for the mapper and the percentage for the reducer, and then a couple more steps and we can download the output of this job. But the moral of this story is this is no way to do data discovery, right? Data discovery, you need to get that answer back right away. Think of all the clicks we were doing in PowerView, and looks like we're at 100% for each now. And in a second, we'll get the prompt back. But it wasn't until the architects around Hadoop kind of came up with an answer to this question that Hadoop really became important to the enterprise. So everything we've been looking at so far is Hadoop version 1. Hadoop version 2 takes us out of this world of batch processing and into a world where we can do things more interactively. So what I want to show you then is if we scroll down here a little bit, this will get the output, and then one more line here, and this will actually list each word that it found in the text and the number of occurrences of each, and it's just doing it in a tab-delimited fashion. Eventually, this will get down to the bottom of the alphabet. Now, word count in a book, maybe not so important, but you can imagine that if you had log files and code that was slightly more sophisticated, you could parse out important things from the log files into key and value pairs and then do interesting aggregations. It doesn't have to be the sum. It could be, some highest spiked value, and you could do this not over, something that was the size of a book, but something that was, maybe the size of 1,000 books, and do that every day or do that every hour. That's why Hadoop is powerful. But the idea of doing all of this stuff on a batch basis can be very frustrating. Let me just scroll up so that you can see some of these words occur many times, like the word year occurs 57 times. So that's good. Let me move this splitter bar back down and just kind of clean up my demo. I'm going to clean up all that output, and we'll be done with our little MapReduce job. But now what I want to do is talk about the technology that bridges the stuff that we're used to in the BI world to this more Spartan kind of environment and makes it all workable. So let's go back to the slide machine and let's talk about that. So the key enabler here is this thing called Hive. Remember in the stack slide, here we go. Right there was Hive, right there. So that isn't just a piece of the stack. That is a really important piece. It is the diplomat from the world of Hadoop into the world of BI. And most BI products that talk to Hadoop do it just by talking to Hive. And Hive has the ODBC and JDBC drivers. So most BI products that talk to Hadoop do it in a very lazy way. They just pretend that Hadoop is another relational database. Okay. It has its own dialect of SQL called HiveQL or HQL. It can work on its own tables, and its tables are really just files in HDFS. It can also work on HBase tables. HBase, remember, is that NoSQL database that works on top of HDFS. And all it really does is generate a MapReduce job in Hadoop version 1. Okay? In Hadoop version 2, you get to benefit from this thing called the Stinger project. Stinger is really interesting because this is Hortonworks. This is Hortonworks saying we want to take Hive and make it actually work as an interactive technology instead. And part of the reason we can do that is Hadoop 2.0 gets rid of this hard-coded reliance on MapReduce. It says, I'm going to take all of my cluster management stuff and I'm going to put that in one place. And then I'm going to put MapReduce in another place, and MapReduce will just be one algorithm of many that can run on the cluster. That means I can take other algorithms or other execution engines. And there's an execution engine called Tez, T-E-Z, and Tez is designed to allow for interactive query on top of Hadoop. And what Hortonworks did was they said, we're going to rewrite Hive to use Tez, and I'll have an update of that stack slide just to put all these strange names together. But what that means is Hive can now work more interactively. And because Microsoft was already partnering with Hortonworks on doing HD Insight, they also partnered on Stinger. And actually, a number of people from the SQL Server team worked on the first phase of Stinger. So there's SQL Server technology in there. There's vector processing in there. Hive has even added the ability to do updates and inserts and deletes, which maybe you're saying, well, what's the big deal there? Well, you couldn't do that before. Hive was really just meant as a read-only system. In fact, the Hadoop distributed file system is, for all intents and purposes, read-only. That's why all those input files were read and then new output files were generated in the MapReduce pipeline, because the idea of updating the input files doesn't exist. So the Stinger project is still ongoing, and this is a big enabler. It means now that Hadoop can work interactively, it can work with BI products, and you can do sort of iterative data discovery. There's still a long way to go, and actually I'm going to show you an even more interesting way of getting at the data in Hadoop when we get to our next demo. Actually, that's right now. So let's switch machines one more time. And we can close this out. We can close this out. And what I'm going to do now, actually, is bring up the Power BI Designer. So this is part of Power BI 2.0. It's in preview, and a good way to think about it is a standalone client that has Power Query and Power View in it, and also has the ability to generate files that can be uploaded to the cloud and then can be visualized using a cloud client. I'm going to show you both. The first thing I'm going to do, though, is I'm going to click this Get Data link. And this time we're not going to go to SQL Server. This time we're going to pick an option that is specifically for Azure HD Insight. Right, there it is. The interesting thing about this option is you can turn your cluster off and this still works, because this is actually going to Azure Storage. And HD Insight projects HDFS, the Hadoop Distributed File System, over Azure Storage. So even when the cluster is down, the data is still accessible, and you can do these kind of analytics. So in this case, we're not going to go through Hive. We're actually going to go straight to the Hadoop file system and move some data in. And if you didn't know, HD Insight kind of comes with one Hive table pre-installed by default for sample purposes. And that file is called Hive sample data. There's a CSV file underlying it called Hive sample data, and we're going to go get that file. I'll click OK here. And we're going to see this thing that looks like a table, but it's actually going to be a listing of all the files in the storage container, essentially all the files in HDFS. And there should be an edit button here, and I'm not sure why there isn't. Hang on. Guess it was the checkbox. So what we want to do is filter on the file name. Remember, it's Hive sample data.txt. It's this one. And we're still going to see a number of versions of the table or the file come back. I happen to know that the first one is the one we want. So once that little filtered query finishes, I'm going to click on this link that says binary, and we'll bring that data in. There it is. Let me click as I said I would. And then we're going to be able to shape the data just like we were doing before with my fact table from the Northwind database. So one of the nice things about Power Query is it can hit HD Insight or actually HDFS on any Hadoop cluster and make any of the files in there come in and look like tables that we can then work against directly. There's some columns here that I don't need, namely the first three and the last two. So let me get rid of those. And then the remaining columns, all I really want to do with those is name them. So this is data for some cell tower stuff. And we're seeing the smartphone platform of the handset, the make of the handset, the model of the handset, the state and the country that the cell tower is in, and the amount of time that the handset and the tower were talking to each other, which is a good thing to aggregate. Then we can get a sense of which models and which platforms are most prevalent. So that thing is called query dwell time. And I can hit OK on that. And then I can just click over here on report. It's going to load the data into the model. In effect, this is doing the same thing that Power Query was doing inside of Excel. And we're going to be able to put a report together just like we did before. And we'll be able to go all the way up to the cloud and see the report from there. If my internet's a little slow here, though, I may switch back to the slides just so we don't run out of time. Let's go ahead and see how this is going to work. Yeah, let me hit the slides, and when we come back, we should be ready to work on this guy. And let me point out that HD Insight is missing a couple of things that a lot of other Hadoop stacks have in them at this point. Keep on your shopping list this thing called Apache Drill. It is becoming a very, very important open source project in the big data world. It works mostly in memory as opposed to on disk. And what Microsoft does do when you set up an HD Insight cluster, they make it very easy to run an optional scripting step. And if you run that scripting step, it will, in fact, install Drill on the cluster. But their cluster doesn't include Drill by default. Drill has several subcomponents to it, and I'll show you some of those on the stack slide in a moment. Actually, everything I just told you about Drill, substitute the name Spark. So Apache Spark is that in-memory engine, and the one that Microsoft makes easy to layer on with the scripting step. Apache Drill is another open source project, and it's interesting because it gives you a SQL interface not only to data in Hadoop, but in fact, data even in a NoSQL database like MongoDB, and it doesn't require you to specify schema to get to that data. So Drill is an interesting product that is on one or two distributions. Spark is an interesting new project that is on most Hadoop distributions. And something else on most Hadoop distributions is a browser-based user interface called Hue. HD Insight doesn't have that either. So I wanted to mention these because even though they're not in HD Insight, they're still important to the ecosystem overall. So the new Hadoop stack looks like this. The first three slices are the same three slices that you saw before, but then the plot thickens. For interactive SQL, now we have the ability to have Hive and Tez together, which is what you see on the right. We also have Drill that I just mentioned. We have a subcomponent of Spark called Spark SQL, and something else from Cloudera called Impala. All of these tend to use that same dialect of SQL. They all go against Hadoop, but they do it in different ways. Okay, and you just end up seeing a lot of different SQL on Hadoop options out there. I tend to think the one that's most interesting still is Hive and Tez. There's also a search layer in most cases now. Apache Lucene and Apache Solr combine to be that search layer in most Hadoop distributions. On the machine learning side, in addition to Mahout now, there is a component of Spark called MLlib. ML is in machine learning. And then there's a layer for streaming data. That would include Spark streaming, as well as Storm and something called Kafka. And Storm and Kafka are available on HD Insight right now. So as you can see, these pieces are changing all the time. This is an ugly slide, but it's probably a pretty important one. It summarizes kind of the state of the art of most Hadoop distributions right now. So that's a slide worth keeping track of. So machine learning is the next piece and probably the last really big piece to talk about. But meanwhile, I wanted to go back and finish up that last demo. Our data is now here. And I just want to show you that a lot of the same stuff that we were doing before, with Power View we can do now, remember this data came from Hadoop. So I could pick the platform and the query dwell time. And then I could also pick the model and the query dwell time and maybe turn that into a line chart. And then we could maybe set up state as a slicer. It defaults to a map, which doesn't really help us, but we can make it a slicer very easily. And we just lost our internet connection. We still should be able to query it locally, though, so that's the good news. Let's bring on country as well, and we'll quickly change that to a slicer as well. Good. And if we pick United States here, and then maybe we pick California, we'll see lots of iPhones, right? iOS is here, and we'll see lots of models. If I click on iOS, you'll see all the Apple models. If I have really good aim, I can click on Windows Phone. That always gets a cheap laugh. Those are the Windows Phone models. And you get the idea. I could then save this file. Let's go ahead and do that. We'll save it as, we'll just call it Ignite. And then while that's saving, we could go to the Power BI website. Log in. And if that internet connection's really gone, then that part of the demo just isn't going to happen. Let me try it over here with the hard line. Okay, I think we're in. And then if we click Get Data and connect and browse, we should be able to get to the, hang on a second, we should be able to get to the workbook that we just saved. Let's just grab that. Wrong window. We want to get a Power BI Designer file, so we'll connect and browse over there. That's the file we had just saved. And what this will do is go ahead and upload it, and then you'll be able to view that same report over here in the browser. And this would work across different devices as well, because this is all HTML5, whereas initially Power View was based mostly on Silverlight. You can take individual visualizations if you want and pin them to dashboards, and that's kind of what you saw up front over here. You'll notice the thing that I just pinned has been added to the dashboard that I had already selected. But again, all this stuff mixes and matches. We might just have time for a quick demo of the machine learning. But what I'd rather do is make sure we finish up the slides. And then if there's 5 minutes left, we'll go ahead and we'll hit that. The thing to remember about Azure Machine Learning is that you build these things called experiments, which are really just workflows of different tasks where you shape the data, and then you build a statistical model on that data, and then if you want, you can run predictions against those models. There's APIs that you can hit so that you can actually integrate those into your applications. And again, we'll demo that if we have time, but let me just hit the other slides here. There's another piece here called Azure Data Factory. Right now, most of what you have to do with Azure Data Factory is create JSON files to define different transformations and data sources and data destinations. And then you end up writing PowerShell code to link those all together. You can see it in diagram format, but right now the tooling's not there to build out the diagram. The diagram's just a rendering of everything you've done in code. I expect this will get a lot more usable as time goes on, though. This is actually built by the same team that built integration services, so a lot of that sort of intellectual capital is going into the product, and the idea is to sort of make it grown up for the big data era. Finally, there's a piece called Azure Data Lake. And it's based on this approach where we say, remember when I said it's just cheaper to store everything than to make a decision about whether or not to store it? So Data Lake says just store everything in HDFS, and then we'll bring different execution engines to process the data in different ways, depending on what the analysis requires. So Microsoft has just introduced a special version of Azure Storage called Azure Data Lake that's meant to deal with this specifically. And it implements HDFS so that Hadoop clusters can use it, but meanwhile it's low latency. There's a lot of parallelism built into it, and we can go ahead and handle a huge amount of data in there, including, by the way, the ability to handle files, individual files that are a petabyte or more in size. Streaming options. We talked about Stream Insight. I mentioned that Storm is available on HD Insight. And then another new piece is called Azure Stream Analytics. Look at that SQL, if you can, and notice the group by in it. It says group by tumbling window, 2nd/5 topic. So this is actually doing query on tweets, and it's cutting everything into 5-second intervals, and it's doing that all with a declarative SQL syntax. That's the easy part of Stream Analytics. The harder part is setting up Azure Service Bus and Event Hub to get the data in the first place. But once you've done that, Stream Analytics gives you a very simple SQL dialect to query it, which is good to have. And then, is my clicker dead? DocumentDB is one NoSQL option, and HBase running on HD Insight is another. The whole point of NoSQL is that you're working not in a place where the schema is really going to be different on every single row in your database, but there may be slight differences from row to row, and you don't want to add new columns to your catalog to deal with that. So you have two choices. One is a fully managed service called DocumentDB that stores data in JSON format, and then the other is what's called a column family database, where you define what the different groups of columns are, but then from row to row you can have different columns within those groups. And then in terms of what will likely come next, the machine learning stuff, and I'm talking about industry-wide here, machine learning will most likely become more integrated into BI rather than being a separate kind of siloed activity. This is a little bit of wishful thinking, but I do think it's going to happen. I think we're going to see streaming data get a lot easier. I think we're going to see Hive get better and better. Hadoop, hopefully, is something that will be under the hood, but not something we have to work with directly. So there's a lot of really good technology in Hadoop, but the idea that we have to go down to the command line and bat it around, eventually I think will be viewed as kind of an early stage thing that just, was destined to go away. Because there are different execution engines available for Hadoop, I think we're going to see Hadoop used not just for big data, but even for smaller data as well. And then this last bullet I'm very happy about, because I made a prediction that Polybase would come down to SQL Server Enterprise, and in fact that was announced yesterday. So The next version of SQL Server 2016 will have Polybase built into SQL Server Enterprise. So all that niceness of being able to query SQL Server with T-SQL and have it reach out to the data nodes in Hadoop will become available without an appliance and without having to use a cloud service. And then Spark, which I mentioned is very hot right now, that will need to either get production ready or it'll need to go away. I'm not sure which is going to happen. I tend to think it'll get production ready just because there's so much hype around it that people have a vested interest in it. In any case, that takes us to the end of this presentation. If you have questions about the machine learning that I didn't get to, come up and ask. And meanwhile, thank you and enjoy the rest of the show.